It's crazy to think that Node came out all the way back in 2009, and technically speaking, it still doesn't support TypeScript. This is one of the big things that alternatives to Node like Dino and Bun got right early. We know that TypeScript won. It's not a debate anymore. We're not sincerely considering TypeScript versus Flow anymore. TypeScript's the language of choice for the JavaScript ecosystem now. It's not necessarily what we're using in the browser for all of our web apps and whatnot, but it is absolutely the language that we're using to build the tools in the ecosystem surrounding the project that we now know as Node. So why don't we support TypeScript? It's kind of a complex situation because supporting TypeScript means a different thing to almost everybody. For some, supporting TypeScript means checking the types, making sure everything is valid, and spitting out an error if it's not. For others, supporting TypeScript means you can put in TypeScript code and it runs. Also important to note that when you have different things like your tsconfig configured in different ways, the result might be entirely different code or will not pass. How does this all get supported in Node? It's a great question, and we've been going around this for a while. The thing we're here to talk about today is this awesome new flag that just got added to Node. But before we get there, we need to talk about an important proposal, which is the TC39 proposal for type annotations. I've mentioned this once or twice before. It's a really important proposal. The goal of it is to add type annotations to be part of the vanilla JavaScript spec, not in a way that they'll be checked and enforced, but in a way that you can copy paste some TypeScript code in the browser and it will just run as expected. Because right now, if I go to my editor, and I'll just write a quick function in this file, function add numbers, and we have A number, B number, return. If I just copy paste this into the browser, we go to console, paste, uncaught syntax error, unexpected token, colon, because these colons aren't valid syntax in JavaScript. This syntax only exists for TypeScript. So I had to delete these and make this function not type safe in order to go define this. And now I can add numbers just fine. But the fact that you have to do that is a problem. And the goal of the ECMAScript proposal here isn't to make it so type safety is enforced in the browser. The goal is to enable developers to run programs that are written in TypeScript, Flow, and other static typing supersets of JS without any need for transpilation. This is the key word, and we need to emphasize this one. Transpilation is most of what we're talking about here. This proposal is full of really interesting things. Let me know if you want a whole video about it. The key motivation is they wanted to unfork JavaScript. Clever pun. But the goal here was to make it so these other languages weren't as far from the JavaScript standard and ideally could all work in the browser the same way JS does. The strong demand for ergonomic type annotation syntax has led to forks of JavaScript with custom syntax. This has introduced developer friction and means widely used JavaScript forks have trouble coordinating with TC39 and must risk syntax conflicts. This proposal formalizes an ergonomic syntax space for comments to integrate the needs of type-checked forks of JS. So this is almost like colons being used for comments in JS, and then they can be used for types everywhere else. Think of it similar to how JSDoc works, where you can leave a comment on top of a function to define the types for it. But as part of the actual TypeScript and JavaScript syntax, we're doing a colon like this, leaves a comment, and then the comma ends the comment. It's a very interesting proposal that has a lot of potentials for wins. The reason they're doing this is that very, very, very many JS devs want static typing in JavaScript. Also pipe operators. Someday, fingers crossed, I'll get my beloved pipe operator eventually. There's some interesting discussion at the end here about how attempts to actually enforce the types have been done, but these have all resulted in non-negligible slowdown. It's actually a fun call out that in 2015, the V8 team, which is the team that makes the engine that powers both Node and Chrome, they were experimenting with a proposal to implement a new JS mode that they called strong mode. Think of this kind of like strict mode, but stronger, where you could enforce types and type checks. And they intended to use types to improve site performance. Google canceled the experiment in failure. In the end, we had to give up on this one. Yeah, it turns out a lot of these types of things tend to cause more performance problems than they resolve. It's hard to get right. There are some projects trying to get this right. Check out my Static Hermes video, all about the custom JavaScript compiler, runtime, and whatnot. That's goal is to make your JavaScript code as fast as the equivalent assembly code. Really cool project by Facebook/Meta and Amazon to try and make React Native apps just instantaneously launch and run. But these efforts are massive and really rough, which is why this particular proposal has the goal of treating TypeScript like a comment syntax instead of like a type-checked strict language. I think this is awesome. I have seen a problem so many times with how people use TypeScript that I think I need to Excalidraw. So we have the TypeScript compiler. So we have this hi.ts file. And what people seem to think happens is this comes out, and if all of the syntax here is correct, on the other side, we get hi.js, which is your JavaScript file. This is not actually how the TypeScript compiler works. Think of the TypeScript compiler like two parts. One part is the type checker, and the other part is the actual compiler that results in JavaScript code. And it's important to know that the compiler, the type checker side of it, doesn't have to be happy for the JavaScript to come out. So you can think of this as there's two parts that come out here. It's harder than it looks. So one of the two things that comes out of the TypeScript compiler is the actual output file. But the other thing that comes out is any errors you have. So I'll make error const hello is undefined. So on one hand, you might get this file that, as far as the compiler knows, could work, could not work. It doesn't know, because TypeScript can have an error on code that is totally valid. Like if we have a function here, we'll just call this add. We say a number, b number. If I call add with hello world, this is a type error, but this code works. So this is why it's important to understand that these are separate things, that the TypeScript compiler both gives you errors and anything that it thinks is wrong when it checks the code, as well as the compilation step where it actually generates the output JavaScript code. The other important thing to know is that doing this part, where you turn the TypeScript into JavaScript, is much easier to do than this part, where you find errors based on the actual syntax, the tree of what's going on in your TypeScript code. This part is effectively transpilation, where we're turning hi.ts into hi.js. We are taking this input and we are turning it into this output. The compiler is also the type checker, which spits out these errors. Want to call this distinction out because I think it's important to know, because right now, this proposal isn't a proposal to check the types and give you errors if they're wrong. This proposal is to skip the type check and just strip all the types out, so you can run the JavaScript code without the TypeScript syntax breaking it. Ahmed just dropped a good meme I wanted to include quick. TypeScript compiler when type checking. Here's my shit code. No, there's 45 places where I used a type that could be unfolded. TS compiler when transpiling. Here's my shit code. Looks good to me. This is JavaScript's problem now. Also of note, I'm not sure if I mentioned this properly before, you don't need to use the TS compiler to do the transpilation. The actual TSC JavaScript package is kind of slow, and there's a bunch of other things you can use to take that TypeScript code and turn it into JS. You can use things like ESBuild, SWC, and so many other things. Did I say undefined? I'm sorry. Reading is hard, okay? I'm tired. Something you'll see on most of my projects and near the end of my tutorials is this set of calls here, where I ignore build errors in TypeScript and I ignore during builds on ESLint. The reason for this is I don't want my TypeScript type checking to block my deployments. I want the TypeScript type checking to be done in CI so that I know if there's an issue and it will get flagged before we merge the code and it goes to main, but I don't want a type check on my deploy as well as on my CI. I'm effectively doing the same thing here that Node is doing, where I'm not checking my types as I'm turning my TypeScript into JavaScript. I am just turning it into JavaScript. And then I have CI that will actually do the type check. I have the PNPM type check and the PNPM lint call here, and these run separately because, again, I don't want to block my deployment on my type checks. And if I can have both of these things running separately on different infrastructure, it means that my demo app can be out as quick as possible in a PR build, and that my actual local CI that's running on GitHub can give me the feedback I need so I know I'm not shipping a mistake. What's the type check script? That's just a super simple package JSON TSC --no emit. Because again, I don't want the output code. I just want to know that the types are good, and this will throw an error if I get the types wrong. So the goal of this isn't so much to get you correct errors in your terminal as you're writing code. It's to make sure you don't need something like TS Node, which is a total mess to set up, just to run your TypeScript code. And this is how other things already work. Like if I'm just going to make a new file, hello.ts, console.log sup nerds. You know what? We'll make this a little more real. Function, hello, name string, cool. Well, console.log hello world. Thank you, Super Maven, for flying through this. So cool. I made this function as a type definition. And if I try to run this with Node, if I just do node hello.ts, it doesn't know how to deal with the syntax. But if I do bun hello.ts, it doesn't give a shit. Dino run hello.ts, same deal. You get the idea. Node's the only one that doesn't know what to do with this. Sadly, this does not seem like something I can easily run right now because it merged literally 5 hours ago. So there isn't even a nightly build up yet. Hopefully there will be soon, but the least we can do now is read through what's going on and what the plan is, because I am very excited to have a strip type built into Node. Node will transpile the TypeScript source code into JavaScript source code. During the transpilation process, no type checking is performed and types are discarded, as it should be. Checking the types yourself is not that hard, as I just showed in this code here. It's literally just tsc -no emit. Now you have your type checker. It's easy to do. Motivation. I believe enabling users to execute TypeScript files is crucial to move the ecosystem forward. It has been requested on all of the surveys, and it simply cannot be ignored. We must acknowledge that users want to run node foo.ts without installing external dependencies or loaders. Yes, absolutely. TS nodes become like a meme, and it is absolutely deserving of being a meme, not because the people who made it are bad faith or anything, but the fact that it is necessary is relatively painful. Why type stripping? Type stripping, as the name suggests, means removing all of the types, transforming the input into a JS module. Here we see basically the exact same example I did here, where we just stripped the colon string. Other runtimes also perform transformations of some TypeScript-only features into JavaScript, for example, enums, which do not exist in JS. At least initially, in this PR, no transformation is performed, meaning that using enum, namespace, etc. will not be possible. Good call out, because there are some things in TypeScript that aren't just stripped. Like enum becomes something different because there is no concept of enum in JavaScript. One of the many reasons you probably shouldn't touch enums, but you get the idea. Anything that's specific to how TypeScript works won't make it through this transpilation. Thankfully, TypeScript's been more hesitant to add features that aren't part of vanilla JS. They're a little eager to add some ahead of time, like they added nullish coalescence, optional chaining, and some of those types of features before they made it to core JavaScript. But they only add things that have been approved that will be part of core JS in the future, which is what makes this interesting, because these older features that were added before TypeScript decided it was going to focus on being as close to JS as possible, those won't be supported properly. So there will absolutely be some code that doesn't work with this flag, at least for now, but there's a future where that changes. Also of note is how they're actually doing the type stripping, because they didn't write a new solution for this. They're actually using SWC, specifically the Wasm TypeScript package. SWC, as described, is the Rust-based platform for the web. It's a set of compilation tools written in Rust to try and make web dev faster. It was originally just a TypeScript to JavaScript compiler to take your TypeScript code and make it into a smaller JS bundle. Think of this as similar almost to something like ESBuild, where it's just the minimal, takes the input, spits out the output part. It's not a proper bundler that handles all of the complexity around getting the right files to the right place, making sure that your bundles are split properly, all of that. It's a top-level transpiler almost that turns the TypeScript code into JS. And this is what's being used right now inside of Next.js to turn your TypeScript code into JS that ships to your users. SWC is a really cool, powerful project, and it's cool seeing it being adopted in these ways, because one of the things they pushed really hard for was Wasm support. Not because they expect you to run SWC in the browser, but because they want SWC to work in every environment. And since Node supports Wasm in every environment, by supporting Wasm, SWC can run everywhere without having to ship a bunch of binaries. This is important because the amount of binaries that have to ship for SWC in something like Next.js is honestly a little bit funny. If we go to my Node modules, Next, SWC, Darwin, ARM64, this is the version I need because I'm on a Mac. But Next now has multiple SWC versions that have support for 32-bit and 64-bit, Windows, Mac, and Linux, ARM, or Intel. So there's a ton of these binaries now that exist in the Next package. You thankfully only need to install a subset of them, but not everything's smart enough to do that right. And you might just have 7 Darwin or not Darwin SWC binaries floating around on your system now. And these aren't small. If we reveal in Finder, get info, that's 100 megabytes just for the SWC ARM64 binding. So having a bunch of those for every operating system, that's not fun, which is why shipping SWC for every single platform as native binaries inside of Node makes no sense, because now you have to eat that for every single platform. And they don't want to do that. They don't want to massively increase the size of Node, but by using the Wasm TypeScript build, they have just one. And since Wasm runs on every platform, SWC Wasm can run on every platform without needing a native binary. It won't be as fast as if they were using the native binary, but now they have to eat way less like straight up bundle additions and cruft in order to get this working. As the author says, I've considered other tools, but they require either Rust or Go to be added to the toolchain. SWC Wasm TypeScript is a small package with a Wasm and a JS file to bind it. SWC is currently used by Dino for the same purpose. It's battle tested. In the future, I see this being implemented in a native layer. Massive shoutouts to KD1 for releasing an SWC version for us. Absolutely huge. And if we go to NPM, we can quickly see that the Wasm TypeScript package just got updated. First and foremost, good to see. But more importantly, once NPM loads, you'll see it's 2.5 megabytes versus this SWC version, an SWC Darwin ARM64, much less so. 115 megs. Yeah, just a little bit smaller. 115 megs to 2.8. Yeah, sorry, 2.5. You get the idea. This is pretty much as responsible of a way as you can implement something like this. I'm honestly really pumped to see it. Amaro is a wrapper around SWC WASM TypeScript, a WebAssembly port. It's currently used as an internal in Node.js for type stripping. In the future, it will be possible to upgrade separately. Amaro means bitter in Italian. Clever, very clever. So they added this new package called Amaro that is the thing that actually does this. Diff is too large. It's 617 lines. What the fuck do you mean it's too large? Wait, it said it was 600 lines. Oh, it's because there's a giant binary here. Okay, I take it back. This is a little absurd. Is that how they're including the package? They just took all of it and put it in as text that's serialized? I mean, clever. That solves the problem. Yeah, they parse this giant blob as a WebAssembly module, and that's how they integrate it. That is kind of hilarious, I won't lie. Who needs to deal with things as complex as NPM and modules when you can just dump all of the contents as text and then base 64 encode it? And then we have the dev deps here. And you'll notice that we don't have SWC as one of the deps because they just dumped the source there. Not even the source, the output binary code. That's super cool. It's always fun reading through these Node PRs. They're full of fascinating things. Node supports both CommonJS and ES module syntax and TypeScript files. Node will not convert from one module system to another. If you want your code to run as an ES module, you must import and export syntax. And if you want it to run as CommonJS, you must use require and module.exports. As in JavaScript files, file extensions are mandatory in import statements and import expressions. Import file TS, not import file. Because of backwards compatibility, file extensions are also mandatory in require. Interesting. This won't work if you're not using the .ts or .js syntax. I never thought they would go that hard on that in Node. It's the right decision. I know that TypeScript's been pushing us in this direction for a while, but I think most people are going to be really weirded out the first time they see in a file like this, common button.tsx. And as you see here, that just breaks for me, which is funny because TypeScript's official recommendation is doing that. I think I have a video about that already. If not, let me know and I'll consider doing one so that we can cover that very, very interesting and controversial change. But until then, I think I've covered all I have to say on this one. This is an awesome change. I am genuinely really excited to see it. It's crazy to think that TypeScript's been out for 12 years and Node's been out for 14. And we're just now getting official TypeScript supported Node. But it shows, once again, how hard the ecosystem is trying to do these things right. I don't want to fault Node or make it seem like they're a failure of any form for not supporting this before. They let the ecosystem do its thing. And now that we've done our thing, they're finding the best possible way to integrate it into the platform. So let me know what you guys think in the comments. And until next time, keep using Bun. Peace, nerds.